Hey, welcome to our channel. In the next 3 videos of our channel, we'd like to talk a bit about surface effects. Do you know what carbonization is, what it means, how to see it, how to identify it, and what it actually means for your application? We'll find out. So, thinking about what kind of video we're doing, I went into our incoming QA and checked if we're having some new findings, some samples, something which is weird, something which is not so good. And I got surprised. In fact, we got deliveries of 1.5 inch and 2.5 inch of 304L material into our inspection. And well, the people are actually pretty, I would say pretty experienced with visual effects on surfaces. And so they got suspicions about these 2 samples. Why? They were checking them, and probably it's a bit hard to find and hard to see, but they had a bit dull and slightly gray and blurry surface. That's what they were suspicious about. And basically, it looks different from the others. And they tried to wipe it off, they tried to peel it off, they tried to scratch it off, but it doesn't go off. And you can also not dissolve it by IPA plug shooting, for example. So you cannot wipe it off, you cannot take it off by IPA. So you may say, is it actually a problem? I mean, if I cannot take it off, it's no problem, right? Or what is the case here? Well, I was a bit curious, and then I had a short view to the microscope with it. So I took the samples and brought them to a microscope, and I had then some other sample here, which is a very much standard tube that we are using. Yeah, and you can probably see it's pretty bright, shining material. And when you look at it via the microscope, you see this kind of surface pattern, I would say. See a pretty regular pattern, a bit grayish, but actually in a quite good condition. And then we were also checking the samples of these 2 specimens here. And probably it's also a bit hard to see, but when you look at it through a microscope, you see a completely different pattern. You see the drawing pattern from the mill, that's what's remaining, but you also see these darker lines and this, so to say, islands in the surface, on the surface. And as I mentioned, it's got a bit of gray appearance. And the question is, what do we see there? And, when you have a certain kind of experience, you see that picture and you probably know what you see. What you see there is carburization. And where does carburization come from and what do we see there? Those are going to be 2 of our next questions that we're going to answer here. What you see there are basically the gray boundary areas or grain boundary lines between the grains of the austenitic stainless steel. And what you see there as a bit of dark appearance is or chromium carbide, which is then formed in between the boundary lines of the grain boundaries here. And so this is a picture when you take this sample further down the road and you take it to a pickling process, you will receive a different kind of sample again, which is again more dark than the original one, because what you do is by the pickling process that you take off some of the remaining stainless steel from the grain boundaries, and you so kind of develop further these chromium carbide structures on the stainless steel. And that's what you see in this picture up there. So you can see that the grain boundaries even got more developed and stronger, and that's why these darker areas on the surface got visible more and more. And that's the effect, what you see in a kind of pickling process. So carbonization in general is something where a carbon, and where it comes from, we will probably find out, is diffusing during the annealing process into the grain boundary areas. So where basically one kind of crystal of austenitic stainless steel is attaching another one. And usually in this grain boundary areas, material can diffuse into the stainless steel surface very well. And that's why you have these lines between the grain boundaries that are becoming so visible. And what it does is basically it's taking away the chromium from the stainless steel to form chromium carbides. So saying that, you may figure already, as it's taking away the chromium, that it may do something with the corrosion resistance of the material. However, what that means to your specific application, it's kind of difficult to say. In case you may have a gas application, it may not be that big of a problem. But in case you may have a kind of critical or more critical application dealing with liquids, you may run into a corrosion issue later on. But this is something we're going to figure out later on. However, this is what I would like to present in this short video to give you an idea about the different samples, the different surface appearances, and what it takes to find that. And it's basically, I would say, experience of a person looking at this very careful, having this quite large background in these visual examinations. So I will now take a look at it again, find out what we are talking about, to characterize that a bit more, and we'll give you the results in one of our next videos. So stay tuned, stay curious, and see you around.